Hey, my name is Mr. Crane. I'm your science teacher, and we're about to do our first lab for seventh graders. This is called the water bottle lab. I created already two videos kind of introducing shortly uh, about the independent dependent variable and the overall lab. What I do want to show you now is the document that you use to record all your information. So if you're in the water bottle section, lab section, it's actually a document created inside the water bottle lab alternative version 7.0.7a. So if you go to the bottom right there, it shows water bottle lab doc. It's a document that I've created for you on the water bottle lab. So what you're going to do is you're going to open up that document. There's a copy of that document. You're going to put your name here, and you're going to just follow along as it reads here. You're going to say, to practice the skills used to design experiments. So we've been covering the scientific method and experimental design. We've learned what hypothesis is, the independent variable and dependent variable, your controls, your constants. So now you're going to put all this into practice by conducting this lab, this virtual lab, basically, because it's an impossible expectation to think that every single one of you have access to a bottle that looks just like this. So, and I can't send them all out to you. So, in this particular lab, it's the same picture that's sitting right up here. You're looking at this image, and I see rates of flow right here. I see the top hole, the middle hole, and the bottom hole. They have four holes there. It should be only three. But given three evenly spaced holes in a filled water bottle, determine which hole will result in emptying the water bottle the slowest or the quickest. So the first thing I need you to do, that's your question, your overall question. Your next thing you need to do is develop a hypothesis. So that's that if-then question. So water should empty from a container at a given rate, depending on the size of the hole and the constant of gravity, which happens or what happens when the holes are evenly spaced apart and timed. So really, there's your question right there. What happens when the holes are evenly spaced? Or um, which hole would result in emptying the water bottle the slowest or the quickest? That could even be your question. So the task is design an experimental investigation, a fair test. In order for it to be fair, it must be testable and must be repeatable, those two things. So all of your classmates repeat the same thing, they should expect kind of the same results. So a fair test. To test the rate of the water flow from a container given three different positions of your holes that we have in this particular experiment. So these are the materials you need. You need a water bottle, a catch container, a ruler, water funnel, data sheet, graduated cylinder, stopwatch, and tape. So for virtual students, the only thing you need is the data sheet because I'm going to provide everything else. I'm going to provide the rates of flow of your fellow class members. So step one is identify the variables. Now you should have already gone through the section where it talked about independent and dependent variables. What is the independent variable? It even says what you will change or the difference between the groups. And you need to find, so it says what are, right below that it says position A, position B, position C. So right here you should be writing your 10 centimeters, my 20 centimeters, my 30 centimeters in that particular section right there. Dependent variables, what you will observe or what you will measure. This is the data that you're actually collecting. So if I'm poking a hole in here, poking a hole here, poking a hole here, not all at the same time, but one at a time, poke a hole here, and I want to know the rate of flow, I'm taking a timer and I'm clicking it. What am I measuring? The rate of flow, but how am I measuring that rate of flow? What device am I using to get that rate of flow? All right, so something, oops, I'm clicking the wrong thing here, sorry. So something that I have access to and you might have access to is a stopwatch on our video right here. So if I hit, I hit start on the stopwatch, it starts to record time. I hit stop whenever it's done and then reset for the second hole, third hole. What is your hypothesis? So you need to write your independent dependent variable and then come up with a hypothesis. It must be in like an if-then statement. If I pick which hole, then I think blah, blah, blah. It's going to be the fastest rate, slowest rate, or whatever. So your if-then. If, there's a blank for you there, and then blank for you there. And then you're going to collect your data. Here's page 3 right here. Step 3, it says, normally during the experimental design process, you will create a procedure that details how you conduct the experiment. Well, I've already done so for you. So we're going to conduct the experiment. You're going to come up with a data for your particular group, and you're a group of 1. So you're just going to be the first column right here. Recorded data for your 10, your 20, your 30. Now I'm going to minimize this real quick. I have data right here that I'm going to input for you. So this was the position A, position B, position C of different trials. And you can determine your data for that, or you can include it. If you want to do this at home on your own, you're more than welcome to. Just follow the procedures, and then you can put your numbers inside this hole, inside this A, B, or C position in this cell. But I have provided that for you. And I'm going to demonstrate this in a different screencast, just showing you whenever I poke the hole and what's actually going on. Okay, so we'll go back down to the data sheet real quick. So we're going to fill that information here. And then I'm going to show you how to build a graph here, watching your tails. So your tails are